We are now starting target 7C. Target 7C is use the characteristics of similar triangles to find trig ratios. Okay. 7C.1. I can write trigonometric ratios of an angle by using the properties of similar triangles. So we are now writing our trig ratios. Remember, your trig ratios are just sine, cosine, tangent, right? So I kind of talks in this rest of this unit, anytime it talks about trig ratios, it's just our three main trig ratios. So I can write the trig ratios of an angle by using similar triangles. So we're going back to what we did in KC6. Again, everything builds. Okay. So let's look at some review first. The first thing I'm asking you guys is, are these two triangles similar? How do you know? This is going all the way back to KC6b. Remember, I have three sides of my triangles. In order to prove these similar, I need to do small over small, middle over middle, and big over big. Okay? So my smallest side, right, I have 3 over 6, which has to equal my middle side, 4 over 8, which has to equal my largest side. I did 3 over 6, 4 over 8, so I have to do 5 over 10. Right? Again, 3, 4, and 5 are all part of the same triangle. Then, reducing my fractions, 3 over 6 is 1/2, 4 over 8 is 1/2. So I'm going to say yes. Triangle ABC is similar to triangle A prime, B prime, C prime by side, side, side. So then, let's answer our following question. So now it's just asking me to find the sine, cosine, and tangent of these. So again, I'm going to start with this triangle. 5 is going to be my hypotenuse. If I'm finding the sine of A, that 4 is my opposite side. And then 3 is my adjacent side. Come on. So then the sine of A move this up just a little bit. Alright, sine of A. I'm going to write SOHCAHTOA up here. Top of everything so we can remember it. Right, sine is opposite over hypotenuse. My opposite side is 4. My hypotenuse is 5. Cosine, adjacent over hypotenuse. My adjacent side is 3. My hypotenuse is 5. Tangent of A, right? Tangent is opposite over adjacent. My opposite side is 4. My adjacent side is 3. That's me. All right. Then, doing the same thing with our bigger but similar triangle. Right? Again, across from my right angle is my hypotenuse. Across from, I'm looking at A prime. So across from A is my opposite side, and then across between my angle and my right angle is my adjacent side. So again, sine of A prime is opposite over hypotenuse. My opposite side is 8 over 10. Again, we have to reduce, and that's 4 over 5. The cosine is adjacent over hypotenuse. 6 over 10. Have to reduce, and that's 3 out of 5. Then tangent is opposite over adjacent, which is 8 over 6, which reduces to 4 out of 3. Okay? So now let's look at these. Well, you know, the sine of A equals 4 out of 5. The sine of A prime equals 4 out of 5. The cosine of A equals 3 out of 5. The cosine of A prime equals 3 out of 5. The tangent of A equals 4 out of 3. The tangent of A prime equals 4 out of 3. So what is our relationship between similar triangles and trig ratios? So when two triangles are similar, then their trig ratios of the corresponding angles are equal. Okay, so when two triangles are similar, then their trig ratios of their corresponding angles are equal. So for example, A and A prime are corresponding because they're the same angle in the two different triangles, right? It wouldn't be like A and like the B up at the top. Those trig ratios are equal. They're different triangles in like the dilation, right? So I still have to look at like the same angle in the triangle. Okay. But those are equal. So we can use that to answer questions about similar triangles. So looking at example 1, if sine of A equals 5 over 13, what is the sine of angle D? Well, angle D and angle A are congruent. So the sine of D is going to equal the sine of A, and the sine of A equals 5 over 13. Okay, so the sine of A equals 5 over 13, the sine of D equals 5 over 13. There's not even any math. It's just that easy. Looking at example 2. Triangle ABC is similar to triangle PQR. If cosine of R equals 4/5, what is cosine of C? Okay. Well, C is here, right? And C and R are in the same place. So the cosine of C has to equal the cosine of R, which is 4 out of 5. The cosine of C equals 4 out of 5. Done. That's it. Let's look at our next example. Example 3. Given triangle ABC is similar to triangle DEF, find the sine of angle A. Well, here's angle A. I don't really know anything. I only know one side. That's not really going to help me. So I'm going to use what I know about similar triangles. Sine of A has to equal, right? A is here, has to match up with D. So sine of A has to equal the sine of D, which equals opposite over hypotenuse. Do I know the opposite side and the hypotenuse side? Hypotenuse. Opposite, I do. Right? The opposite side is 200, we can put our adjacent here, 25. Our hypotenuse is 350. If I reduce those fractions, I get 9 out of 14. And that's it. Okay? So if I have these similar triangles, I can use the other triangles to find my trig ratio there. Our last example for this one. Given triangle HJK is similar to triangle LMN, find the tangent of angle N. So same thing. Since I'm given the similar triangles, the tangent of N, which is here, has to equal the tangent of K. So I'm going to find the tangent of K. Okay, here's my right angle, so I have my hypotenuse side, my opposite, my adjacent. Tangent equals opposite over adjacent. which equals 3/4. That's it. Go ahead and work on C1.